Good morning, students. This video deals about RAID disk arrays of the memory system. What actually RAID? Redundant array of independent or inexpensive disk. Redundant array of independent disks or inexpensive disks. What is an RAID? It is a data storage virtualization technology that combines multiple physical disk drive components into one or more logical units for the purpose of data redundancy, performance improvement, as well as both data redundancy and the performance improvements. What actually the need? Why RAID is needed? Because of sustained exponential improvements in semiconductor technology, that is a processor speed or main memory capacity, over the past decades as compared to the slower improvements in secondary storage technology, a widening performance gap exists between the two. The effect of this is that the latter is becoming more and more of a bottleneck that serves to impede the rate at which overall system performance can improve. Hence, much research has been directed towards discovering the way of configuring the secondary storage system to improve their performances. Perhaps the best solution to have been developed so far is RAID, redundant array of independent or inexpensive disks. Let us see about the RAID in detail. It has a two orthogonal concepts. One is going to be data stripping, second is going to be redundancy. Let's discuss about data stripping. The data stripping is used for improved performance. Data stripping distributes a data transparently over a multiple disk unit to make them appear as one large, faster disk unit. This allows the multiple disk IOs either from the different request or different parts of the single request, which is to be performed in parallel. Second one, redundancy, which is for improved the reliability. To extent using a multiple disk rather than one, which lowers the overall reliability in terms of an mean time to failure (MTTF). Thus, the redundancy data is going to be stored in order to make a recovery possible in case of simultaneous failures of a small number of disks in the array. So that a number of different data stripping and redundancy schemes have been developed. The combination and the arrangements of the schemes leads to a prevailing set of options for users and designers of disk arrays. So each option presents a subtle trade-off among reliability, performance, and cost. And most of the RAID organizations can be distinguished based on two features. Let's discuss about these two features. First one is nothing but granularity of data interleaving, which has been subclassified and fine grained and coarse grained. What actually this fine grain? Which results in high data transfer for all IOs, but has disadvantage that only one logical IO request can be in service at one time because all the disks are needed for each IOs na. And second disadvantage, all disks must take time to seek for every request. Such a way it's going to have a drawback over there. Second one, the coarse grind, which allows the multiple small requests to be serviced simultaneously if those requests are each of them of a small amount of data. The second feature is nothing but modern method and pattern, in which the redundant data is going to be computed and distributed across this disk array, which is going to decide the modern and method and the pattern. Next, there are two more orthogonal issues are going to be present over there, which is one is nothing but the which method to use for computing the redundant data. For example, a parity or a Hamming code or read Solomon codes, so which is going to make some issues over there. The second issue is nothing but how to distribute the redundant data across the array. by using a small number of disks to store redundant data, or all of them, whether we have to use a small number of data or all the data has to be. This may be later is going to be, it tends to spread out the work evenly among the disk, which avoids the bottleneck phenomena also. Let us discuss about the RAID levels. So actually 7 levels are going to be there. The first 1 to 5 levels, level 1 to level 5, are going to be given by the Patterson, the original author, which have been given, and this is level 0 and level 6 have been given by other scientists. Let us discuss one by one. Level 0, it's a non-redundant data stripping or a data stripping. Here the data stripping is used to exploit parallelism, but no redundant data is going to be stored, which has a best performance of write operation, because no redundant data need to be stored, but not the best performance on read, because there are no choice as to where to get the data as there is in. The level 1, which is going to be called as mirroring or shadowing. Here, for each disk drives which uses a mirror or a shadow, thus there are always two copies of all the data. For each write, must write data on two disks. For a read, which can choose the one that can serve or service the request more quickly. If a disk failure, then its mirror is going to be used to restore the data. Next one, level 2, memory style ECC or error correction codes. For example, here we can use Hamming code for error detection and correction. Assuming that we are going to use a Hamming codes for the error detection and correction. For an array of 4 disks, there need 3 extra to be stored redundant information. So storage efficiency increases as the number of disks increases. It becomes possible to detect as well as correct the errors in the bits. Next one, level 3, bit interleaved parity, which uses only a single extra disk for storing the parity information. Conceptually, the data is stored on the disk interleaved on a per bit basis. If a single disk fails, the rest can be used to recover its data. Here, each write access all the disks including the parity disk. For each read access all but one extra is going to be accessed. Then level 4, a block interleaved parity. Similar to a level 3, except that the data is interleaved across disks in blocks of arbitrary size, which is going to be called as stripping unit. Here, read request smaller than the stripping unit access only one disk, whereas write request must update all indicated data blocks plus each corresponding parity block. The fact that a single disk is used for the parity causes a bottleneck. Every write must access the parity disk. Coming to the level 5, block interleaved distributed parity. The parity data is distributed onto all the disks, which has the best small read, large read and large write performance, whereas small write not so good compared to mirroring because of need to perform a read modify write operation to update the parity. This is a major weakness of this level 5 block interleaved distributed parity. Let's move on to the seventh one, level 6, P plus Q redundancy, which has a stronger error correction capabilities to protect against simultaneous failures of two disks. These are the 7 levels, starts from level 0 to level 6 of RAID. Let's discuss about the optical disk. What actually optical disk? An optical disk is any computer disk that uses optical storage technique and technology to read and write the data. It is a computer storage disk that stores data digitally and use laser beams to read and write the data. It uses the optical technology, light technology, in which a laser light is centered to the spinning disks. Uh, you can come across this types of CD-ROM, nothing but a compact disc which is available in that read-only memory, recordable, rewritable, and DVDs, which is nothing but a digital versatile or a digital video disc, and DVD RAM. These are the types of optical discs. The next one, the generally, if you're going to see about that, the optical discs are generally used to distribute the software to customers, and sometimes stores large amount of data such as an video, audio, or images. Some kind of information can be stored in this optical discs, and which can transfer the data to a different computers or devices from one to another. And sometimes we can use this optical disk to take or to retrieve some of the backup data from the local machine. These are generally general uses of the optical disk. Move on to the next topic, magnetic system, magnetic tape system. What is a magnetic tape system? A magnetic tape is a data storage system for storing the digital information on magnetic tape using the digital recording. Tapes was an important medium for primary data storage in early computers, typically using an large open reels of 9-track tape. Now, modern magnetic tape is most commonly packed in a cartridge or a cassette. The device here, which the device that performs the writing or reading of data, is going to be called as tape driver. The tape data storage is now used more for system backup, data archive, and data exchange. It's a low cost of tape as kept in visible for a long-term storage and archive. So this figure, which is going to show the organization of data on the magnetic tape, it's a gap, file gap is going to be there, file will mark will be present over there. So the data can be stored from this record to the file which have been mentioned over there in the record gap, and it's nothing but 7 or 9 bits are going to be present over there to keep the file marking. This is about the magnetic tape system.